Hello, today we continue solving problems on determining the empirical molecular formula. I propose that today we solve the following problem. We have a certain sample of a substance which is described as follows. This is a solid substance with an orange color, and its formula needs to be determined. It is known that a sample of this substance has a mass of 1.308 grams. It contains potassium, which weighs 0.348 grams, contains oxygen weighing 0.498 grams. It is known that the remaining part of this sample consists of the element chromium. We need to determine what our empirical formula for this substance will be. So, look at how we will solve this. Since we know the mass of our sample and it is known, since potassium and oxygen are included here, let's first calculate how much chromium is present in our sample. To do this, from the total mass, which is provided to us, we will subtract the mass of the potassium present, and accordingly, the mass of oxygen. And it turns out that our sample contains 0.462 grams of chromium. That's all, and now we proceed to calculating our formula. So, let's follow the plan below. What elements are included in our orange-colored substance? It's potassium. Let's put chromium in second place and oxygen in third place. Because oxygen is usually listed in formulas, most likely it's a salt in the last position. So the mass of potassium is 0.348. Next, the mass of chromium, which we just calculated, is 0.462, and the mass of oxygen is 0.498. The mass is given in grams, and in this case, we observe the mass ratio. Now we will divide the mass of each of these elements by their relative atomic mass. In fact, we will be determining the molar ratio or the mole ratio. Then, for potassium, we will divide 0.348 by its mass of 39, and let's be more precise, 39 and 1 after the comma. Next, for chromium, 0.462, and we'll take the mass of chromium as exactly 52. And for oxygen, 0.498, and we'll round the mass to 16, rounded to 2 significant figures after the decimal point. Now, in the next step, let's find out what our ratio turned out to be after the division result. The first digit is 0. 2 zeros, 89, and let's leave one more digit after the number 9. Here, the ratio comes out with the number 0.20, 888. And here we get 0.0311. Now we need to find the simplest ratio for this. We will see that the smallest value is this one, which belongs to chromium, and we will divide all the others by it. So it turns out we will be dividing 0.008090 by 0.00888. We will relate this value to the result obtained here by dividing it by itself. Well, and the last value we have is 0.0311 divided by 0.00888. Now we obtain the smallest prime numbers that result in integers. For potassium, this will be 1. For chromium, this will be 1. But for oxygen, it turns out to be 3.5. But 3.5 is not a whole number, so we will need to multiply all the numbers by 2 because we want the smallest integer. Value, and then we will get 2. To 2, and here the number will be 7. These numbers are already integers, and then our formula is easily derived from here. And so we have 2 potassium in this case, there are 2 chromium in our example, and we have 7 oxygen atoms. Thus our substance turned out to be a salt called potassium dichromate. This substance is indeed represents a solid orange substance that is very commonly used, for example, in organic synthesis, oxidation, and also this substance is used, for example, as a means for treating leather, for instance, to give it a glossy finish, which is why this substance is quite widely used in various fields. And so in this way, we solved it and found the formula using calculations related to grams in this case. I hope this task is clear to you. Goodbye.